Hello students, in this lesson we are going to learn about RLC series circuit. An RLC series circuit is an electrical circuit that contains three main components connected in a single loop with an alternating current AC source. These components are a resistor R, an inductor L, a capacitor C. In most practical AC circuits, these three elements usually appear together. Each one plays an important role in controlling how current flows in the circuit. Before we go deeper into RLC circuits, let us quickly review the basic relationship for resistor, inductors, and capacitors. Resistors. When resistors are connected in series, the equivalent or total resistance is the sum of all the resistance. R is equal to R1 plus R2 plus R3. But when resistors are connected in parallel, the equivalent resistance is given by 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This means the total resistance becomes smaller when more resistors are added in parallel. Capacitors. For capacitors in series, the equivalent capacitance is given by 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3. However, when capacitors are connected in parallel, the total capacitance is simply the sum of the individual capacitance. C is equal to C1 plus C2 plus C3. Inductors. For inductors connected in series, the equivalent inductance is the sum of all the inductance. L is equal to L1 plus L2 plus L3. For inductors in parallel, the equivalent inductance is given by 1 over L is equal to 1 over L1 plus 1 over L2 plus 1 over L3. Let us also remember the key equations relating voltage, V, current, I, and other quantities. For a resistor, the relationship between resistance R, voltage V, and current I is given by Ohm's law. R is equal to V over I. For a capacitor, the capacitance is defined as C is equal to Q over V, where Q is the electric charge and V is the voltage. For an inductor, the induced voltage is related to the rate of change of current by V is equal to L, change in I to change in T. Energy stored in circuit components. Each of these components can also store or dissipate energy. For a resistor, the electrical work done is W is equal to QV. For a capacitor, the energy stored in the electric field is work done is equal to half QV. For an inductor, the energy stored in the magnetic field is work done is equal to half Li squared. Example. The energy stored in an inductor of inductance 5 millihenry when a current of 6 ampere flows through it is an inductor has an inductance of 5 millihenry and a current of 6 ampere flows through it. We are asked to calculate the energy stored in the inductor. First, let's recall the formula used to calculate the energy stored in an inductor. The formula is E is equal to half Li squared, where E is the energy stored in joules, L is the inductance in Henry, I is the current in amperes. Before we substitute the values given in the question, remember that millihenry must be converted to Henry. So 5 millihenry is equal to 5 times 10 raised to the power minus 3 Henry, which is equal to 0.005 Henry. Substitute the values into the formula. E is equal to half times 0.005 times 6 squared. E is equal to half times 0.005 times 36. 0.005 multiplied by 36 is 0.18. E is equal to half times 0.18. E is equal to 0.09 joules, which is 9 times 10 raised to the power minus 2 joules. Your answer is D. In summary, an RLC series circuit contains a resistor, an inductor, and a capacitor connected in one loop with an AC source. Each component affects the flow of current differently. In the next lesson, we will look at how these three components interact together in an AC circuit and how to calculate impedance and resonance. Thank you for watching. Keep learning.